Let's take a look at number 1, and I've already written up there one of the forms that might be helpful. That is to take and expand it, to multiply it out, and then take the derivative of the expansion, and you come up with choice E that way. The other approach that you might take is the chain rule, where y prime, or dy dx, would equal twice whatever on the inside raised to the first times the derivative of the inside, which would be 3x squared. So bringing that all together is 6x squared times 3x plus 1, and that's probably the most efficient way to go. So you have two ways to go here. Either way you go, E is the answer. On number 2, we have a simple integral here. A small substitution might be in order. So let u equal negative 4x. If that be the case, then du would equal negative 4 dx. And of course you don't need that negative 4, so you might want to say that negative 1/4 du is equal to dx. So making my substitutions, first for the dx, let's put in the negative 1/4 way out front, and we've got our du. And now we're going to have e to the u, of course. And my limits are 0 and 1, but let's wait on those. Let's just evaluate. Won't that be negative 4th e to the u? And if we back substitute, won't that be negative 1/4, and it's going to be e to the negative 4x, right? Now let's bring back our limits, our original limits, 1 and 0. And if we put those in, don't we get negative 1/4 e to the negative 4 out front? And if we put 0 in, don't we get e to the 0, or 1? Now as we look to our answer choices, it seems to me that if you multiply this out, you get negative e to the negative 4th over 4 plus 1/4. And although it doesn't line up exactly, D is certainly the equivalent, right, for number 2. On problem 3, we have a situation where we're asked about a horizontal asymptote. And the thing to remember here is that horizontals, anything can happen in the short run. If this is our line, y equals 2, a horizontal line, anything at all can happen with the function in the short run. It's just that eventually it's got to be headed towards that asymptote in the long run in both directions. So E is saying exactly that. As x gets very large, the function is going at 2. It's got 2 as its target. Vertical asymptotes won't be crossed. Horizontals, anything can happen in the short run. What's important about horizontals is that eventually the function moves toward them. And that's problem 3. Number 4 is a quick problem if you know the quotient rule, dy dx, and remember we often write that as y prime, would equal the bottom times the derivative of the top less the top times the derivative of the bottom over the bottom squared. So let's see what's going on with that top. If we multiply it out, don't we get 6x plus 4 minus, don't we have 6x plus 9? And again, it's all over that common denominator, 3x plus 2 quantity squared. Don't the 6x's knock each other out? don't we have 4 minus 9, which would give us that negative 5 in the numerator, and in the denominator 3x plus 2 quantity squared. And that matches up perfectly with the answer D. And the fifth problem, the fifth installment here, is taking the integral of sine, and the integral of sine is negative cosine. So this guy is equal to negative cosine. That's the integral of sine, right? And our limits are pi over 4 and 0. So negative cosine pi over 4, putting that upper limit in, minus a minus cosine of 0. The cosine of 0 is 1. The cosine of pi over 4 is negative square root of 2 over 2. Well, it's square root of 2 over 2, but it's got a negative sign in front of it. So it seems to me that this lines up with D perfectly. And this brings us to the end of the first 5.